Alright, the next topic that we need to address is song saving and loading. Up to this point we've got a song system in place. We've seen that it can play songs. We've got a rendering system in place so that we can see our songs. Now it's time to address saving the actual song data to a file on the hard drive so that it can be loaded back at a later time.
Okay.
Now, in order to do this, we're going to need to come up with a format to use when saving our songs, and we're also going to need to come up with the location in which songs will be stored. So let's address the location first. Up here in our Solution Explorer, let's jump up to our Content project. We will collapse the Style folder. Then let's add a new folder to Content, and we'll call this folder Songs. Now, in order to get this folder created in the target project, what we're going to do is jump out here anywhere on the hard drive, and we're going to create a new text file. We can call this blank.song. The only reason we're doing this is I want to make absolutely sure that a folder gets created, because here in a minute we're going to be writing code that's going to need to write to the folder.
Okay.
And the code is going to simply assume that the folder exists. So all we're going to do is take this blank file, drop it into songs. It doesn't really matter what the file is as long as the content pipeline doesn't try and build it. As a matter of fact, we'll swap the build action to none, and the copy to output.
It's still set to compile.
Oh, okay, I must have missed. That's what I get for clicking too quickly.
No worries.
Alright, copy to output, copy of newer, build action none. So just to verify, I'm going to hit F6 and build the project. And then I'm going to jump into the actual project folder for the drum game, jump into drum game, then, not content, jump up to bin so we can get access to our output folder, here under debug, content, songs, and then we have the blank song. Just visually confirming that this songs directory exists.
Okay.
Because once again, we're going to assume in code that it does. Alright, now we're ready to jump into the code and begin setting a few things up. First off is going to be a little bit of path information. Various pieces of our code throughout the game are going to need access to the song's folder location. So we'll follow the same pattern we've been following so far, and we'll go up under Global State and set up a new path field. Inside of Global State, we can copy our style path, and we can change this field to songs path. Then we'll set the folder name to match the folder we created up here in the content project, which is songs. Alright, this takes care of the path from the relative sense. We now need to remember to go into our game class, game 1, and expand the path to an absolute path. So here in game 1 we have our game's constructor. So let's copy the expansion code used on style path and apply it to song path. So song path will be path combine our content path with global state dot songs path. And looking at the code, you know what, just a matter of preference, but I think I'm actually going to change the name songs path
To just song path singular?
to just song. Yeah, exactly. So song path will be songs. That'll make it feed nicely with things like style, song, content.
Right, right.
Again, really at that point it's just a matter of preference. So, alright, done being picky and time to move on with code. Alright, now that we know where our songs are going to be going, we need to put the actual saving code together. And we're going to write this song saving code inside of the base song class. So we'll jump down here to song inside of our core folder. We'll bring it up, and at this point, to clean up some of the space we've got open in Visual Studio, I'm going to close everything except the song class, just to clean all that back off.
Yeah.
Alright. Now, inside of our song class, let's jump down here to the bottom, and we'll drop in the framework for a new method. We're going to create a method called SaveSongFile. We'll make the method public, void, and we will call it, of course, SaveSongFile. And we're going to take in a file name, so the name of the song to save. Now keep in mind that this it's an instance method, so the idea is that you address a specific song instance and you can then tell that instance to save out to a file. So that's why we're only passing in a file name here. Alright, now let's jot some quick notes down as to the things that we'll need to do. We're going to need to make sure we save a few core pieces of information as well as the data held within the notes list. So the pieces of information that we'll need to recreate the song instance will be things like the BPM, the quarter note definition.
Right, because we were using that to derive all the other notes.
Exactly. So the quarter note is almost like our core resolution. So we need that in order to make sure we reestablish the song with the same resolution. We are also going to store 2 additional pieces of information that will let us define our time signature. So we'll have the ticks per beat and the beats per measure. So with this information, we'll be able to store the format of the song, things like resolution and time signature. Then after we store those pieces of information, we'll then need to store all of the notes. So we'll say all notes, and we'll store the notes in the format of tick, comma, track. And just a quick note on the actual way we'll store these. What we'll do is we'll put together a simple text file. So we'll set up a file that's meant to be read line by line. We'll set up each line to be divided up into 2 fields or 2 columns, separated by a comma. So actually what we'll end up with is something like BPM, comma, 120 to indicate a BPM of 120. Then we could have something like quarter note, comma, 96 to set the resolution of our quarter note, so on and so forth.
Sure.
Once we get down to the notes themselves, in order to keep everything unified to where everything follows a 2-column format, tick and track will be something like maybe tick 384, comma, track 2. So we'll have lines which look like that for each of our notes.
Gotcha.
Alright, with this in mind, let's begin writing this in the form of some actual code. The first thing to do is to open up a text file that we can write to. And to do that, we're actually going to use a stream writer. Now, at this point, we do not yet have a reference to system.io, and that's going to become helpful in addressing the stream writer. So let's drop in a using statement for system.io. Alright, with our namespace now opened, we can go back to the save song file method, and we can make a new instance of a stream writer. We can call this instance writer, and we'll turn around and immediately instantiate a new stream writer. We'll use the second overload, which allows us to specify the path to a file, and we will simply pass in the file name parameter. Now, once we get done with all of the writing we might do here at the end of the method, we'll make sure we turn around and dispose of our writer. Writer.dispose. Alright, now that we've got a writer, if at this point we have succeeded in opening the writer, we'll have access to the song file, and we need to begin writing data, beginning with our BPM, quarter note, and so forth. So let's look at putting together our first line. We'll look at writer, and we'll tell it to write a line. We'll let WriteLine take care of putting the necessary end characters at the end of the line to signify the new line. Now, inside of WriteLine, let's put together the string that will hold our data. We're inside of WriteLine, just like using console.WriteLine, we can actually specify a format string and then a series of arguments. So for the format string, let's address our BPM line. So we'll put together a string BPM, comma, then embraces argument 0. Then we can pass that argument in here as this.bpm.
Cool.
So very simple formatting. WriteLine will take care of putting that on its own line. And now we can move on to quarter note. I'll simply duplicate the writer.WriteLine command, and we can move on to quarter note. So we'll make a second line in the text file that begins with the name quarter note, drop in a comma, argument 0, and this time argument 0 will be this dot quarter note. Now we can jump out, duplicate the line. Let's do 2 more times. That way we can address our ticks per beat and our beats per measure. So we'll make a text column called ticks per beat, and naturally we'll save this dot ticks per beat. And finally we can write down beats per measure and drop in this dot beats per measure. So that takes care of all the formatting data. Now we need to write all of the notes from the notes list to this file, and we'll accomplish that using a simple for each loop. So we can bring up for each, tab twice to drop in the template, and we'll look through the notes collection, and then each variable we'll pull out we'll call note. So for each note in notes, then all we'll do is we need to assemble another simple line, which is in the format of number comma number, or tick comma track. Once again, I'll snag one of our existing writer.writeLine lines, only this time we'll drop in two numbered braces, two arguments. So we'll have argument 0, comma, argument 1. Then argument 0 can be the current note inside of our loop dot tick, and the second argument can be note dot track. And since that's the only line we're going to have inside of the for each loop, I'll pull out our braces. And at this point, I'll also pull out our comments because we're addressing everything: BPM, quarter note, ticks per beat, beats per measure, and all of the notes. Since we have that all now nicely represented in code, we can pull all of that back out. Alright, with our newly created SaveSongFile method, it's now time to turn around and test it. Let's jump into our game class. So down here in game 1, we'll pull that back up. And let's jump down to the initialize method. Here in initialize, let's put together a song instance, use the beat generator to populate the song with notes, and then use our new method to save it back out. So I'll make a song instance. We'll call this variable song and instantiate a new song. Now we'll immediately turn around and address the beat generator, where we will tell it to generate beat 1. We'll pass in the newly created song, and we'll say that we would like to have 4 measures worth of notes. After this runs, we should have a populated song, so we can turn around and address that song and tell it to save the song file. Now for the file name, we'll pass in a path which we'll need to assemble using song path and then the actual name of the song. We'll use path to do the path assembly. So we'll grab path.combine. We'll drop in our song path, which is held in global state dot song path. Then we can address the name of the song itself. And we'll take beat 1 and we'll call it rock.song, since it is a basic rock pattern. Now we can end off the call to combine and the call to save song file, drop in a terminator, and now we can try running the game and seeing if this write method works. So we'll give it a second to build, and nothing has exploded, so let's close out of the game, bring up our project folder once again, where we're looking at the actual output folder, our songs folder we looked at a moment ago, jump into songs, and now we have a song in addition to our blank song. Now to look at the data in here, let me try dragging this here into Visual Studio, directly into the editor, and now I can look through the data we have saved out. We see we have the first 4 lines, which denote tempo and then the resolution and time signature of the song, followed by a series of lines which have tick values followed by track values. So everything seems to be working very nicely.
Very cool.
Alright, while we're in here generating and saving songs, let's actually save out our other 2 beats 2 and 3. Let's drop in beat 2, and let's call that 2x bass.song. Then we'll run an exit, and then we'll grab beat 3, and we'll call this one 6/8 time, since we used it to test out 6/8 time inside of our generator. Alright, with the game having been run, Let's jump up to our folder where we now have 2 more song files. We'll drag both of those in just to preview them. So we can see that our 2x bass song has a tempo of 180 and time signature of 4/4. 6/8 time has a tempo of 100, and we notice that ticks per beat is different than the value of a quarter note. So that's where we're getting the tick value for our dotted quarter note used in beats, and then fewer beats per measure. Alright, with all of these loading in and saving nicely, let's go ahead and call this video here, and in the next video we'll take a look at loading this data back in to a song instance.
Excellent.